thank you for joining our live audience. As with every episode, we'd love to take your questions live during the show. That's the whole point of this live show. And welcome to HuggingCast V2. This is the second episode of our new live show about open source AI. So I think I really appreciate you coming on at this time. So HuggingCast, what is this thing? We want it to be a cross between a podcast and a webinar. We want to talk about the latest and the greatest developments in our beautiful world of open source AI. And we also want you to walk away having learned something practical that you can apply in your work. So in each episode, we'll walk you through hands-on demos and show you demos. And we want to make this interesting, fun, short and sweet, hopefully. So we won't use the full hour today. We really want to try to keep the show at 45 minutes. Last time we said
we can
half
try.
An hour and we made an hour. But we'll try.
Let's see.
We can do better. Let's do 45 minutes. People have a weekend to go to. And
of course,
we're excited to take your questions. So yeah, ask them while we're speaking. We'll get to them when we have the time. I'm Jeff Boudier. I'm on the product team here at Hugging Face, and my co-conspirators and fellow casters, the cast of the HuggingCast, the heroes of the demos, Philipp Schmid and Julien Simon. And today, I'm really excited to bring onto the show our first special guest, Leandro von Werra, co-author of the Transformers book, and also today the lead of Big Code at Hugging Face. And we want to learn all about StarCoder, the latest code large language model. But before we start, I think we have a little bit of celebrating to do. We achieved two super exciting milestones last week that we want to share with you. And for that, I have a prop.
Oh, no.
That's the prop. All right,
that's embarrassing. That's embarrassing.
It's
so
okay,
80s, Jeff.
So today, this week, we're celebrating 100,000 stars for the Transformers library. Yes, if I had a little sound effect with the applause, like that's when it would come on. It's really amazing to see Transformers be the second project in history to reach that milestone for machine learning. Congratulations to all the community for all the contributions that came to the library. And to celebrate this, our team, the Transformers team, put together a really cool page on the Transformers GitHub to surface 100 projects, 100 awesome projects that were built with Transformers. So from GPT for all, you got MindsDB, LangChain in there, ParlAI, Sentence Transformers, of course, Paddle NLP, Stensa, Alpaca LoRa. I'm not going to name them all, but all of them are really awesome projects from the community built upon Transformers. So thank you, community, to help us reach that historic milestone. Second thing we want to celebrate, we celebrated last week, is the hub reached 200,000 open source models, freely accessible models on the hub. This is an amazing milestone. And so, yes, thank you, community, for continuing to share with everybody the results of your work. So 200,000 models free and accessible to use on the Hugging Face Hub today. Congratulations, Hub team. All right. So that was the congratulations bit. Now, I want to turn on the news. So on the news front, we also had a couple of very cool announcements since our last show. The first one is our partnership with IBM. So I don't know if you've seen it. We have a little URL for you guys to check it out. Check out the blog post on it. If you want to put that on the ticker. So on the blog post, you'll learn all about our partnership around watsonx. watsonx is a new platform built on open source to do safe machine learning within the enterprise. And so it's super cool for us to be able to contribute to that. Something that we're working right now with IBM, and that will be really, really powerful for the enterprise. So the two worlds are colliding, and it's very, very exciting. And then another announcement that was just this week at the Microsoft Build conference, we announced a native integration of the Hugging Face Hub within the new Azure AI Studio. So you can go in there and find a model catalog that's called the Hugging Face Hub with like 1,000 models that you can deploy in place. It's a couple clicks. And we really love to know what you think about the experience. It's brand new, so there's lots for us to improve and add to it. All right, so that's for the news. And now I want to turn it to Leandro, our special guest today. Thank you so much, Leandro, for joining us. Over the past couple of weeks, I've kept talking about StarCoder, and I've been really, really excited about this model release. And one narrative that I've been saying, and I want to know if you think that it's correct, is that StarCoder in a way changes the narrative that I've seen over the past 6 months, where the open source community were sort of working together feverishly to catch up on like black box proprietary models, closed source models, and we're quickly catching up with those models. And I feel like with StarCoder, we're flipping the narrative, where actually the open source model in many respects is better than the proprietary closed source models that came before it, right? You have OpenAI Codex, you have AWS Code Whisperer, you have GitHub Copilot, all these things. So I wonder, like, in your opinion, like, is that a fair characterization? And like, in what ways is StarCoder better than those proprietary models?
Sure. Yeah, I mean, StarCoder is really exciting. We try to measure how good StarCoder is like across many domains. Just like one thing people are usually interested in is just like, what's its pure performance, right? So we try to benchmark it on standard code benchmarks, and it seems to be either outperforming or matching Codex, a Copilot. We don't know exactly the models that are powering Copilot. We have some guesses, and the way it looks like StarCoder is like on par or better on some tasks. I mean, in my opinion, the true power of StarCoder is not its sheer performance, but also that it's open, which will allow people to do two things. One, they can host it wherever they want. They can do whatever they want with it. They can have it locally. A lot of companies can't use Copilot because it's like sending code to some remote place, and code is usually like one of the most guarded like IP inside a company. But and the other thing is that if you open source a very powerful base model, the community will quickly adapt it to all sorts of use cases and build cool things with it. And I think that's something that we saw quite a lot with like Stable Diffusion and also Llama, where it's like, as soon as there's like a very strong base model, the community will take it from there and build so many cool things that like a single team never could come up with.
Thank you so much. And another thing that was super exciting for me about not just StarCoder, but generally the Big Code project is the work around the data set. And you released a blog post recently showing in full detail the work that went into deduplicating data. And there was a lot of data, I think over 1 trillion tokens from 80 different programming languages. I was excited about the fact that you guys had from the get-go an opt-out mechanism so that developers can say, hey, don't put my GitHub project into your training data. And I was also excited about the fact that you guys only pulled data from permissive licenses. So as a business, like I'm not going to run into the risk that there's some code completions out there in my code base that come from data that was not meant to be integrated into commercial applications. So can you tell me a little bit about like how the Big Code as an organization functioned and made those decisions as it relates to the data set?
Sure. So Big Code is an open research collaboration. So in general, anyone who is interested in building code LLMs, they can join and contribute. It's led by Hugging Face and ServiceNow. So we kind of sponsor the compute and the resources to actually train those models. But we want to take like everyone along with the ride because we think like if you want to build like trust and transparency in a system, you want to do it in the open so everybody can see what we're doing. I think there have been lots of discussion what kind of data went into Copilot or Codex and also GPT-3 or 4. Nobody really knows what's in there, so you don't really know whether you should use the model if it was like ethically or responsibly sourced. And so we try to do these things in the open. I would say like we spend probably 60-80% of the time on the data set rather on training models. We found pretty early that like you can get the most boosts by making a better data set rather than iterating on like fancy model architectures. For the model architectures, we mainly focused on the things that we thought would be useful and make the model more performant and easier to deploy. But we spent like lots of effort on the data set from like, as you said, starting with very strong near deduplication. We ran some ablations figuring out like how should you filter a data set for code. There are many ideas that were around, like should you look at like how many comments are in a code file and say like if it's only comments or no comments, that's maybe bad. So find like the middle, or should we look at GitHub stars and only consider code that had at least a few stars? We found like GitHub stars is like a bad idea. That's the only thing that really hurt. All the other handcrafted rules that we came up with for high quality code data, they didn't really work much or didn't make a significant difference. The thing that always made a difference is deduplication. So we decided after some initial experiments, that's the way to go and just focus on that. So we had a 6 terabyte data set. Originally, we selected some languages, most popular programming languages, but also trying to include like some domains that maybe are interested in also using code models. For example, like people that use MATLAB or Mathematica that were maybe more like in the sciences, or SPS for like statistics. And then we kind of like filtered it down to I think 200-300 gigabytes. So like most of the data we threw out of the window, which is like a sad thing. You start with like a big pile of data, and in the end everything melts away. But we found that was actually better than training on a lot of data that was of like mediocre quality. In fact, one thing that I always find a little bit surprising is like it's better to deduplicate and then train more epochs rather than less deduplication and only train one epoch. So if you get rid of a lot of like the duplicates or near duplicates, it doesn't hurt you if you train for a few epochs actually.
Did you train StarCoder on like multiple epochs, or like was it like one epoch like equal to 1 trillion tokens?
No, I think we had 250 billion tokens roughly in the training data set. So I think we ran 4 or 5 epochs for the training. Yeah. And if you look at like the progress, you see like it doesn't like stagnate after one epoch. It's just like goes still up, which is quite nice.
And do you think that's related, since like the data set is already quite huge, so like that you go through like the same samples multiple times is like not leading the model to overfit? Or where do you think it comes from that it's okay to run like multiple epochs? Because I think like the Chinchilla paper or like the previous research rather suggested to only train for one epoch.
Yeah, I think we internally, some people at Hugging Face ran some experiments to see when does it start to hurt when you train multiple epochs, and what they empirically found is like roughly 5 epochs or so is fine. After that, you're better off if you have more data. I think the reason why strongly near deduplicating is better and then run multiple epochs is because you kind of get rid of the natural distribution of duplicates. For example, in code, probably 80% of your code are like boring config files and I don't know, things, unit tests that are very similar. But if you run near duplication for like a certain type of config, you only will have it once. And if you train 5 epochs, you're going to see it 5 times. And before, if you don't do near duplication, maybe you have that file like 50,000 times in some form. And then if you run 5 epochs, you're going to see it like 250,000 times. So that's where it's really hurting.
Awesome.
That's awesome.
We got one question from like the chat. Maybe Leandro, you can help us better understand what is near duplication without going into the technical details. So how could I explain it to my mom, for example, like what it is?
Sure. I mean, the simplest thing you can imagine is maybe you have a form and that form has a template where it's like name, I don't know, your address and so on. And like 90% of the form is always the same, but like the things that you fill out, those are the things that are changing. And a nearly duplicate is something where like most of the text is the same, but only like a few small things changes. And that's happening very often in code where you have like boilerplate code that you just copy paste. And maybe you adapt one value, but it's like, if you look, is it equal? It's not equal. But if you look at like what's the overlap is maybe very significant.
So I guess like the difference to exact duplication or to like to duplication, what we know from like regular human understanding is that we have like snippets or sequences which are pretty close to each other and then we remove them, right?
Yes, exactly. It's like you look at like how much of a document overlaps with another document. Exact deduplication is like the whole document is exactly the same, and near deduplication is maybe 95% of a document is the same.
Awesome. Last one from me. So I understand there was like lots of Python in the training data. There were also like lots of notebooks in there. I know there's like a reinforcement learning from human feedback version, Star Chat that came after it. So like what were surprising things about the StarCoder model or Star Chat model that came from all that training data?
Yeah, there were like a few surprising things. The reason why we included Jupyter notebooks is because we found they're like surprisingly, or not maybe surprisingly, but they're very high quality data where you have a lot of tutorials with lots of text, not only about programming, but also about like physics or electrical engineering. It's like you have this circuit, now compute, I don't know, some properties, and then use some code to do it. And another interesting thing you have is like the output. So the model can learn what a piece of code would produce because the cell outputs are still present in the notebook. And we did some small experiments, and you can use the model kind of as a Python interpreter, where it, like you presented a piece of code and say like, what's the output of that code? And we'll try to generate it. Doesn't always work, but sometimes. So that's a fun thing. Maybe the most surprising thing was we did train it on like a little bit kind of like conversational data, mostly in terms of like GitHub issues that were in the pre-training data as well, where like people discuss issues about code. And when we had like a first checkpoint of the model, one thing we tried to do is like Anthropic released a long time ago, or not a long time ago, but like a while ago, a prompt. They call it the HHH prompt, which is just like lots of examples of conversations. And they found if you prompt the model with all these conversations, usually if the model is good enough, you can then chat with it. And we found that actually also works with StarCoder. So without any fine tuning, or instruction tuning or RLHF, just giving it a prompt with lots of examples of coding questions and answers and like things like that, you can then start to talk to the model, which is like when we did that the first time, that was very magical. I think it's like you have a code model, but suddenly it can also talk.
Wow, that's amazing.
Awesome.
Thank you so much, Leandro. We promised everyone we're going to make it 45 minutes. Let's see if we do it. It was really amazing to talk to you. Thanks for telling us about StarCoder. Check it out on the Big Code organization at Hugging Face on huggingface.co. Thanks so much, Leandro.
Thanks for having me. It was a blast.
Awesome.
Have a nice session.
All right. All right. And now I want to turn our attention to transformers, agents, and tools. And transformers, agents, and tools was built by the transformers team as the boldest release yet of transformers. So in a nutshell, you can use a large language model as an agent that's going to break down your problem into smaller problem. And I think something super exciting is that you can use any of those 200,000 free and accessible models or your own private models as transformers tools. So to tell you more about it, how it works, Philipp, please take it away. And I think you need to zoom in a little bit because I can't really make it. Yeah.
So
awesome.
That's currently, so transformers, as Jeff mentioned, has now agents and tools. That's so like the first like release of the whole agent domain, I would say, for transformers. An agent, as Jeff mentioned, is a large language model which generates an output which is then executed. So we are going to show it to you in a second, but we are asking the model to do something like caption the following image, and what our agent then does is it generates Python code which will then be executed and uses a tool. And a tool could be anything you could really imagine. We already built quite a lot of tools for like the typical pipeline use cases, so that you have models for image captioning, for text classification, for translation. Those can all be used as tools, but you can also write custom tools to do whatever you want to, for example, like query a database, to do a Google web search, to, I don't know, get creative and even execute maybe a JavaScript snippet. And that's done by tools. So we have agents as like the brain, which is a large language model. And then we have tools as use case specific models or executions for doing a certain thing. And a tool always has a description that is then used by the agent to know what to do, and then like the code, what it's going to execute. And the transformers agents documentation walks you exactly through what it is. So like the first example we have here is that our agent we're asking our agent to caption the image, and we have the image provided as input variable. Or we could also ask the agent to read something out loudly. And the cool part here is that you can concatenate those. So you could have a real chat interface where you start with generating an image, then asking maybe to like what is on the image, and then like getting a response back. Okay, we see a beaver swimming in the water, and then you could say, okay, but please make sure that the beaver is not swimming in the water, it's on a tree, and then let the agent regenerate the whole new image basically. Yes. And what we are going to do now is we really like look into really using it, and documentation, let me quickly go back, links a Colab notebook at the beginning. And this Colab notebook allows you to try out and use agents and tools. And what is super cool about it is that you don't need to rely on OpenAI or large proprietary large language models. So Hugging Face agents and tools work locally and work on-premise or in private environments. And currently, of course, we support OpenAI large language models, but you can also use StarCoder, as Leandro mentioned, and also the Open Assistant model. And we are going to use StarCoder. And we quickly heard from Leandro why we can use StarCoder, probably most likely because they train it on Jupyter notebooks, and StarCoder can now generate code based on input. And the notebook basically installs first Transformers version to make sure we have the latest version.
Can you zoom in a little bit?
Yeah, sorry.
Thank you.
And then we have, we can select our agent we want to use. And depending on the agent you use, you either need to provide an API key or a Hugging Face token, since the agents are currently or like accessible in the notebook through an API call. So if you want to run the whole thing in your environment, you need enough compute to run the agent. For StarCoder, it's a 15 billion parameter model. For For the Open Assistant one, it's a 30 billion parameter model, plus all of the tools you want to use. But of course, tools can also be available through remote APIs, meaning that you could have like different models deployed and then let the agent request all of them. And then we can use our agent, and here we are going to generate an image of a boat in the water. And what is super cool, you can see what really happens behind the scenes. So the code generated by the agent is then automatically executed. So we asked our agent, hey, I want to generate an image for a boat in the water. And then the agent understands this prompt and generates, okay, what could be the Python code for it to execute it based on a few shot prompt we provide and based on the description and information from the tool. And here we get a boat. It's not swimming in the water, but we can regenerate again. And that's all that happens. And the model used to generate our images is now running inside the Colab notebook. And of course, can be changed. Currently, the default model for the image generation tool, I think, is the Runway Stable Diffusion model. And but you can like adjust it to your needs. So if you are building an agent system in-house and you have your own, like, let's say, classification model for your support request, you could imagine building a conversational chat agent for your support coming in, and then have your own classification models trained on your customer support data, which classifies, okay, what type of support request do you have? And then you can basically use the agent to request a tool to your classifier to understand, okay, I'm having a email verification request. The model is executed, then you can like return back to, or like execute a second tool. Okay, if it's that case, the customer needs to like go to XYZ or something, and then like have the customer chat with your agent, and the agent uses your internal tools, which could request your database, which could also request, of course, models you customly trained. And then like the notebook basically walks you through a lot of cool examples on how you can use tools. Here we use our boat image and ask the agent to caption the image. And again, we can see, okay, what it is going to do. So the agent thinks basically, I will use the following tool, Image Captioner, to generate the caption for the image, and then it generates the code, and then this code is executed. So always be careful about which tools you use, because it executes basically remote code. So it's not that we are calling an API, that's really code that is executed at the end. So always make sure that the tools you use and provide to your agent are safe and secure.
Super cool. Yes. And well, first, like there's a great comment from Juan Carlos. We say it would be nice to have a community event to add more tools to the agents. I couldn't agree more. One of the great things about Transformers tools and agents is the extensibility, like how easy it is to create a new tool and push that to the hub so you can use it with your agents. And I think a question that a lot of people are asking, and Shubhadeep here asks it on behalf of everybody, which is like, hey, everybody knows about LangChain, like in terms of breaking down problems with agents, chain of thought, etc. It's like a very exciting project, and we built lots of integrations with Hugging Face. So like, how is Transformers agents and tools different from LangChain, and like when should people think about using it versus LangChain?
Yeah, that's a great question. So LangChain is really amazing and awesome if you want to work with API LLM. So most of the features you currently see in LangChain for agents or the chains they added are normally always tested with big proprietary LLMs. So all of the agents you see powered by LangChain are normally running the OpenAI models or the Anthropic models, which makes it then difficult if you adjust your LangChain project to use an open source model. Most likely the prompts and how it is structured internally is not going to work with those open source models. And with Transformers agents and tools, it's basically built for open source and for the models. So the idea behind Transformers agents and tools is, okay, you can use it with open source models and agents, but you can also combine both. You could create a tool which then uses LangChain, or you could use LangChain to then use a tool from Transformers. I wouldn't see them as like competitors, just where probably you need to think about, okay, what's my use case? What do I want to achieve? If you have a use case where you might want to read some kind of documents, then LangChain is of course stronger with all of their different document loaders from S3, from, I don't know, like Jira, GitHub, basically anything available. And if you are allowed to use proper like APIs, like for OpenAI, LangChain also would probably be better, since they already have built a lot of tooling around using those OpenAI models. But if you really want to build something completely on the open source, which needs to run inside of your environment, where you want to really understand, okay, what's the model used behind the scenes, what is trained on, then probably Hugging Face agents is the better solution. And if you want to combine both, you could use, for example, LangChain to create your few-shot prompts or to create your chain. And inside the chain, you could use a Hugging Face tool to, I don't know, like translate a certain text or use a model to classify some input.
Awesome. Thanks so much, Philip. I'm super excited about the modularity.
One quick thing to mention. So we talked about those tools, and some tools are integrated into the transformers library, like image to text, text to image, text classification, question answering. But there's also a way to host and put your tools on the Hugging Face hub as Create Your Space, which then can be used by anyone. So for example, the team has built something called text download, which is a space, but also a tool. And each tool has like a library or like a class which inherits from the tool class, and then a call. And each tool, as we already discussed earlier, has a description, okay, basically describing when the agent should use the tool. And then it has a tool config, and then you can load it similar to models and datasets from the hub. You can load tools from the hub as well. So you can build a tool for the community and then share it with your friends or with whoever who might be interested. So the awesome part here is that it's way easier to distribute and create like a platform similar for models, for tools. So it's way easier to get or create new ideas and then use them in your applications.
That's really, really awesome. Thank you so much for walking us through Transformers, agents, and tools. The boldest release yet for Transformers. I'm super excited to see what the community will build with it. And on the business front, I saw a lot of great content come from you, Julien, over this past couple of weeks. I know you've been all over the place, but somehow you managed to put out some videos from the Hilton series.
Oh yes, the Hilton series.
And like a couple of things that I really want you to dive a little bit deeper on is one, you ran a benchmark to compare sort of speeds you were getting with AWS Trainium versus GPU. I would love for you to give us a little bit of a download there.
Sure.
And then anything else you want to share with the Hugging Squad?
Yeah. So it's hardware optimization is a very important topic for customers. Those transformer models are awesome. They get more awesome every day, but they're large, and training them fast and running inference at the proper speed is always a challenge. And so we have those hardware partnerships with Intel and AWS and a few more that will be announced at some point. We've been working. The two things I want to mention, and I shared my screen. I guess you probably need to put it on the. Thank you very much. On the screen here, the first thing I want to mention is a really interesting experiment that we've been working on with Intel. So, obviously Intel is building CPUs. They have this new generation of Xeons called Sapphire Rapids, and they're running all kinds of experiments on optimizing large language models for Intel CPUs, right? And in this particular example, they describe everything in the blog post. They apply a new quantization technique, which is called smooth quant. It's still relatively new, and in a nutshell, smooth quant does a much better job at quantizing large language models than previous techniques. Okay, you can read all about it in the post. And they try different models, the OPT models from Facebook and Alpaca, Vicuna, et cetera, and they report some really, really interesting improvements. And they also built a demo, so obviously a space demo, where they use a 7 billion MPT model and use it for chat applications. So let me ask a question, maybe. I was in Germany yesterday, so let's ask a question about that. I was in Cologne, right? Okay, so right, so ask a question and I get some, I get an answer. And you could say, well, what's the big deal, right? There are hundreds of models who can do this today. Well, I guess the big deal is this is running on a single CPU.
This is fast.
Yes. Yes, let's follow up.
What is that? Is that like 10 tokens a second?
It is fast, right?
It's even
So
more. Yeah.
I mean, it's faster than you can read it, which I guess is enough, right? And so as mentioned here, this is running on a single Intel CPU, right? And the magic here is obviously the hardware acceleration support in those Sapphire Rapids chip. It's called AMX, Advanced Matrix Extensions. You can read all about it. And the fact that obviously quantizing will accelerate, shrink, I guess, compress and shrink the model. So this goes to show, obviously GPUs are interesting and there's room for everybody, and there's clearly room for CPU inference. We've known that for NLP for years, but now it looks like we can also run smart chatbots on single CPUs, which is, from a cost perspective and just a flexibility perspective, is very, very interesting, right?
Wow,
So
that's really, really cool. But like, just to hammer down the point, like,
yeah.
when you switch from like a GPU instance to being able to use a Xeon Sapphire Rapids CPU, there's like a huge cost difference. Like, what is it, like 10x or?
Yeah, there is a significant cost difference, and those instances are still in preview on AWS. They actually became generally available on the Google Cloud a couple of days ago. So if you're using GCP, you can use those C3 instances and start doing the same. And yes, and it's just simpler to work with CPU instances, right? I mean, like, for once, um, GPU memory is not a problem anymore because there is no GPU, right? So you just load the model in memory. You can actually load multiple models on the same machine. So I guess the inference stack, to me, feels much simpler. And if you want to repurpose that server, to become a database server, then fine, right? It's a fast machine. It's a fast CPU machine. You can use it for anything. So I think from a cost and flexibility perspective, this is super interesting. So we have this Optimum Intel library that our colleague Ella is working on. Hi, Ella, amazing job. And so that smooth quant technique is going to be soon available in Optimum Intel. You can already do quantization, but Ella will keep adding more techniques, so that all that stuff is literally going to be maybe one line of code away or two, and you can do the same, right? So that's for Intel. We're super happy about the partnership, and to continue making friends, on GPU, obviously. The second thing I want to call out is, we like AWS Trainium and AWS Inferentia too. Pretty, we love them, right? Philip, at least Philip and myself love them. I think Jeff
I
loves
love
them.
them.
All right, we all love them then. We think they're really cool chips, and we work hard with AWS to make transformers fast. And of course, we want benchmarks, right? So I did a YouTube video about a week ago where I compare AWS Trainium versus the NVIDIA 100 GPU, and in fact, the P3 instances on AWS. And so a lot of folks jump at me and say, "Oh, no, that's not a fair comparison." And I will take it to the grave. It is a fair comparison because in most AWS regions, the only thing you can grab is P3 instances and V100s, right? I think P4s are only available in 7 out of 31 AWS regions. And even in those regions, I can testify it is very, very hard to grab A100s. The reason why I have a hard time doing that A100 benchmark is because I cannot get an instance. So I'll have to beg and get one from somewhere else. So you can go and look at the video for the exact benchmarks. I just want to, in the interest of time, I just want to show you the results. So I run 3 training jobs: pre-training, language pre-training with GPT-2, token classification with BERT large, and image classification with the vision transformer. Okay, and I compared the largest Trainium instance with the largest V100 instance on AWS, and you can literally see the results here, right? Oh, sorry, that that last line here. So from a training perspective, a training time perspective, Trainium is roughly 2 to 5 times faster than the largest V100 instance, and it's, let's say, 2.5 to 8 times cheaper. So imagine that. Usually it's one or the other, right? You can train more cost effectively, but it's going to be slower, right? Here you get faster training and lower cost. So what's not to like?
I was going to ask you about the money, because that's really what I care about here.
Yeah.
So yeah, that's impressive.
So cost performance, cost performance is the thing you need to look at. Not just cost, not just performance, cost performance. And in this case, you get improvements in both dimensions, and I think that's really great. So again, go look at that stuff. I'll put the link to the video in the chat if you're interested, and I'll give the mic back to you, Jeff.
Thank you so much, Julien. I think we're technically achieving our 45-minute self-imposed goal here.
Yeah.
But of course, I'll linger around to get some questions from the community. If you have questions you want to ask us, go ahead. It's a great time right now. Otherwise, we'll turn off the show and invite you for the next one. Okay. I have a question from Insub. Are there anything you need to change the code to run Habana chip? And I think by Habana chip, you mean Habana. So Habana offers the Gaudi chips. There's Habana Gaudi and Gaudi 2. We do a lot of work with Habana to make it super, super easy for you, so you don't have to change your code too much. So earlier, Julien showed you the Optimum Intel code base. You can find it on GitHub. It's open source. That's how you can get all the acceleration that we're building into specifically for Intel chips. Earlier, Julien showed you how he ran the benchmark for Trainium that was using the Optimum Neuron open source package, where we build all of the stuff that makes it super easy for you to use Trainium and Inferentia. And with Habana, we built the Optimum Habana. Do you want to pop up the link here for people?
Sure,
with Optimum Habana, it's really a line code change to be able to take advantage from the acceleration of the Habana Gaudi chips, accelerators.
Yeah, and
so
for Inferentia, it's one line as well. Like I said, to compile, to run models on Trainium, you just need to replace the vanilla transformers trainer with the Trainium trainer. So that's it. One Python import. And for Inferentia, there's no change at all. You just take the model, export it for Inferentia, and load it there.
And for people who don't know the Habana Gaudi chips, so Gaudi 1 is available generally on AWS, on EC2, on SageMaker, so you can use it super, super easily. And Gaudi 2 is out there. It's not yet on AWS. I hope it will be very, very soon. But you can get it from Intel and Habana, and we've been working to show you the kind of results that we've been able to achieve with it. So, great question. And Igor was asking, where can we find more information on Intel-based speed improvement? So first off, every time we run new benchmarks and analysis, we try to share that out to the community. So if you go on our blog and search for Intel or Habana or Trainium, you will find a lot of great resources.
Yeah, there are quite a few posts on Intel. Yeah.
And then, of course, as I said, go on our GitHub, you will find all of our open source repositories where we walk you through examples on how to use it and what sort of results you can expect. And John Gwyn is asking about, is that Habana? So it's Habana. It's not Havana, but I like it. Is that a benefit for training only? So the accelerator is a general purpose accelerator. Gaudi 1 was really built for training use cases, but with Gaudi 2, we're actually getting great performance on inference as well. So you can think of Gaudi 2, I think, as a general purpose accelerator. Specifically for ML workloads.
Yeah, I just shared the blog post. This is a recent one where we show 3x speed up on Bloom Z, I think, on compared to A100s. So that's a good one. Again, go look at the blog. Look at the blog. Lots of Gaudi stuff, lots of Trainium and Inferentia stuff, lots of Intel. I mean, we keep, Phil and me and the team, we keep posting stuff. We're in love with hardware acceleration. Everybody loves benchmarks, so we're benchmark geeks. There's lots of content.
All right, and I guess to close the show, Daniel gave me a little bit of a hand there. So thank you very much, everybody, for joining. We're also looking forward to the next one. We'll send you an email to remind you when the next show is going to be, probably in 3 to 4 weeks. Thanks again for joining in this not most convenient of times, like wherever you live. It's Friday. Have a great weekend.
I have to say it's my fault. It's my fault because I was traveling.
It's not your fault.
Nah, it was. I couldn't do it. I mean, it was either this or literally do it at the train station. So it was not an option, right?
Well, I'm glad we did it, and I'm grateful for everybody for joining. Have a great weekend. If you're in the US, happy Memorial Day, and see you soon.
Bye.
Bye-bye.
Bye.
Thank you.